Here we are at our example 10 from our 4.6 set of notes. We're told that a cliff diver is hoping to perform acrobatic dives at a height of 92 feet. If the diver jumps upward with an initial velocity of 5 feet per second, how much time does the diver actually have to perform the acrobatic maneuvers before hitting that water? And so, pretty much, again, we always start off with like a quick sketch just to kind of help us put things into context with the scenario. What you have here is a diver at 92 feet jumping up. And obviously, when you jump up, you really can't go very far when you jump up. So that's why that initial velocity is pretty small. It's only 5 feet per second. And then finally come down until, obviously, they splash in the pool. And so that kind of splash that we're looking for is 0. So our final height there is kind of is more 0. In honors algebra 2 and algebra 2, they start to change up that height a little bit. For some of our tiers in the past, I've usually done that, but for us for today, we'll just keep it at 0 for that final height. Now, the first part of this is recognizing our height versus time actual function. And so this is a function you guys are going to encounter quite a bit in the future. It is h of t equals negative 16t squared plus that initial velocity multiplied by time and plus that initial height. That's what that h sub 0 means. Okay, so this v sub 0 represents initial velocity, and that h sub 0 represents initial height. Now, if you're curious what this negative 16, like how that comes about, it actually has to do with what we call gravitational constants, where here on Earth it's represented as a negative 16. If you were maybe on the moon, it would be a different value, or Mars would be a different value, but that's why we have a negative 16 there. If you're talking about like meters, I want to say it's negative 9.8 or negative 4.9. It's one of those two, but most of the time we use the feet per second because, we're Americans. So, and so what we're going to go ahead and do first is plug in our values where they appropriately belong. So we have h of t, I should say, equals negative 16t squared plus v sub 0 is 5 feet times time plus that initial velocity. They're jumping again from 92 feet. And that h of t, because their final destination of where they're ending up is in the pool, which is at 0. Again, that's kind of more just where they're landing. It doesn't necessarily have to, in other scenarios, have to be 0. You can end up in some other height. But for us today, right now, it's just going to be 0. Now, again, we're going to identify A, B, and C. So there's A, there's B, and there's C. Rewriting our quadratic formula, it is x equals the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. And so when we go ahead and plug those values in, we end up with x equals the opposite of 5 plus or minus the square root of B, in this case is 5 squared minus 4 times negative 16 times our C value here is really big. It's 92 all over 2 times our A value is negative 16. And now we're going to go ahead and clean this up. So we end up with x equals negative 5 plus or minus the square root of 5 squared is 25. And this negative 4 times negative 16 times regular 92 comes out to be 5,888 all over negative 32. Now we're going to go ahead and combine our like terms inside of this square root. And when we do that, we have x equals negative 5 plus or minus the square root of 5,913 all over negative 32. And this is actually a part where we start to because we can't exactly do good and garbage with this 5,913, Because we're talking about real world applications, oftentimes we start to include the calculator in this process, and this is where it kind of becomes more apparent, where we have -5 plus or minus this square root of 5,913 roughly comes out to be about 76.896 if you were to round, all over -32. And now we would take the negative and the positive version of that. So when you do -5 plus 76.896, we would end up with over -32. We would end up with about -2.24675. Whereas when we do the positive version of this, I'm sorry, the negative version of this, so that operation, we would get x equals -81.896 over -32. And a negative divided by a negative actually gives us that positive value that we're really hoping for. And so then as a result, you would get x equals about 2.55925. Okay. So again, there we just kind of broke it up with the positive version and the negative version. This would be the positive. This would be the negative version. Now, when you think about real world applications, you can't really ever have a negative time. And so this answer would be excluded just because you're kind of like, really what that's representing is if you followed this quadratic, you'd be working backward in time and seeing that, oh, that's where it ended up. But this diver is really at a time of 0, and he jumps up and then comes down. So you're not really working necessarily back in time. Instead, what you really care about is that time where it is about 2.55925. Okay. So imagine this diver jumps up, he eventually comes down. It takes him about 2.5 seconds until he reaches that pool. But again, these are real world applications, and especially when you start to see these in your Algebra 2 class, your physics, your AP Calc classes, whatever, this is where you start to more include the calculator when you can't necessarily do good and garbage. Again, though, that is example 10 from our 4.6 set of notes.